upward to the cloud. All right, perfect. So we're talking about linear equations. They have x to the first power. That's how you know at just a glance whether your equation is linear or not. Okay, our whole first unit is really focusing on linear equations. So our goal to solve a linear equation we want to isolate the variable. That's our fancy term for get x by itself. All right, so we're going to start off easy, and then, oops, sorry. Then we're going to make things a little bit more interesting. The lighting is always, that's good. All right, so let's try something like, let's start off real easy. How about 2x plus 7 equals 17? So what do you do first? Jay. Of course. So it's basically doing order of operations backwards. You're sort of unpackaging this. 17 minus 7, of course, is 10. And then I divide by 2, right? All right, cool. Easy peasy. Let's try something a little bit more interesting. What if you had something like, oh, I don't know, 20 equals 5x minus 3x? What are you doing with something like this to start off? Jimmy? Yes, I have some like terms on that right-hand side, don't I? So I'm going to combine like terms where I can. So this now becomes 20 equals 5x minus 3x, of course, is, everybody, 2x, and then I can just divide by 2. All right. Let's try something like this. What if you had, got an example here. Go ahead and try and solve that one. What happened? Sam. Yeah. So what happens here, 4n minus 4n just cancels each other out. So I'm left with something that just says 1 equals 1. Well, that is a true statement, right? 1 does equal 1. That's true, but my variable is gone. So whenever you have something like that, when that happens, but you're left with a valid statement, I just don't have a variable anymore. That means that all real numbers would work. They're all solutions to that original. So no matter what you plug in for the variable, it would still be a true statement. So if you plugged in 100 for n, it would still work. If you plugged in -0.2, it would still work. It doesn't matter. So when this happens, so let's say when you are left with a true statement, but the variables, I'll say the variable has been canceled out. Sometimes we use the symbol for all real numbers because why not? So if you are familiar with the symbol, it's just a capital R, but it has like 2 lines. So that is our symbol for all reals if you don't feel like writing it out. All right, let me give you another one. Let's try, let's sneak another one from us too. Try that one. Couple more steps here. Let's see what you can make happen on this. Anybody get an answer? What you got? -8, you say. Anybody else get -8? Good. That is the correct answer. So if you didn't get -8, let's figure out why not. So I'm guessing that most of you distributed first. Did everybody distribute first? Okay, I would do the same thing probably. So -84, let's distribute that too. I got a 2x minus 12, and then plus a 7x. So I do have some like terms to combine, so I might do that next. 2x and 7x, I got a 9x. And now I'm just gonna finish that out. I wanna get the x by itself. I wanna isolate that variable. Let's add that 12 over. So I'm really subtracting here because I have opposite signs. So that's -72. And then we'll just divide by that 9. So yes, I agree with the -8. I know you know this, but just to reiterate, one of the beautiful things about algebra is that when you have an equation and you get a solution, you don't just have to be like, well, I hope that's the right answer. You could check and see if that's the right answer. You could always take that, plug it back into the original, and it should end up giving you a true statement. Okay, so I always encourage you, if you are taking a quiz or a test and you've got some time left over after, take a couple answers and throw them back in, because it's so easy to drop a negative here or miscalculate there. So if you have the time and you throw it back in to check it, you might as well. I'd rather you catch a mistake than me. Okay, I got another tough one for you. Sneak it in right here. Before we start talking about fractions, everybody's favorite. Try this one. 8 equals -4. Let's see, 3 plus 4x. 2 times 8x minus 2. Try that one. Let's see how we do. Just a little bit. Did everybody get 3? I tricked you. That's not the answer. Did everybody get an answer? What'd you get? No solution. I got no solution as well. Let's see why. Why is this no solution? Oh my gosh. Well, we have to distribute first. So we're going to distribute twice. So I've got a negative 12 minus 16x. I got to distribute a positive 2 over here. Plus 16x minus 4. All right. I've got some like-hand terms. I have some like terms on the right-hand side. So let's combine those. So let's see, I have a negative 12 and a negative 4. Those will come together to make a negative 16. But then look what happens in here. I have negative 16x and a plus 16x. They cancel each other out. That's gone, right? What is this business? Does 8 equal negative 16? No, it does not. That is not a true statement, but my variables have all canceled out. So when this happens, it's a very different scenario than when I do have something that's true. When I end up, I call this a bogus solution because 8 does not equal negative 16. So when that happens, the variable is still gone, but I end up with a false statement. That means that there is no solution to this. No number will work. You can try anything you want. Nothing is going to work out. So I'll just add a when the variable cancels, but the statement is false. There are no solutions. All right, how do we feel so far? Okay-ish? You ready to step it up to some fraction action? I knew you would be. I gotta flip the page, so I'll give you another couple seconds to get to write anything else down. So don't forget, when I'm done with the lesson, I will be posting a copy of these notes. Oh, I gotta tell you how to even find them. I'll tell you when I do it. And so yeah, so if you do miss something, just know that will always be this copy available to you should you need it. Okay, all right, let's try some fraction action. We'll start off with an easy one. And I think I'll make it up. I'm gonna make it up. So I have no idea if this number will come out nice or not. We'll see. Okay, so I'm even gonna give this a title, Dealing with Fractions. In equations. Oh my gosh. I gotta figure out this lighting. What the heck? It was fine a second ago, and now it's like, hey, I'm gonna freak out on you. There we go. Let's try, how about a half x minus 3/4 equals 7/10. I don't know, something like that. Where to begin? Where to begin? I'll tell you one thing. There's an easy way and a hard way to tackle this. Everybody know the easy way? Yes. Yes. I can clear the fractions. If you have an equation, there's no need to deal with a fraction if you don't want to. I mean, you can. So the hard way, in my opinion, would be to add 3/4 to the other side, because now you got two fractions you're going to try and add together without common denominators. You've got to figure out that denominator. Then you got to deal with the 1/2. Nightmare. How about we just work smarter and not harder and say to ourselves, hey, listen, let me look at all my denominators here. I've got 2, 4, and 10. If I can think of a number that 2, 4, and 10 all divide into, I can multiply the entire equation by that number and all the fractions will disappear. So I just need the least common multiple of 2, 4, and 10. What would that be? 20. 20. Don't all of these denominators divide evenly into 20? So that's going to be like my magic number here that's going to erase all of my fractions. Okay, so I'm going to give you just some, I don't know, helpful hints. Just going to make a little list here. Helpful hints. So first thing I would do is if you happen to have a mixed number, so if it's like 2 and 3/4, change it to improper. So we don't have any here, but if I did, I would want to change them. So change any mixed numbers to improper. Okay, and then I'm going to find a common denominator. For all denominators, and it has to be on both sides, not just one side, the whole equation. And then we'll go ahead and multiply every single term, even if it's not a fraction, right? Because sometimes you have equations where some are fractions, some are integers, right? So I want to multiply every single term, whether it's a fraction or not, by whatever that common denominator is going to be. Now I'm going to add right here my little saying, and you'll understand what this means more in just a minute. We're going to divide down, multiply up. It's sort of a fast way to do that. All right, so let's go ahead and do that with our equation. So we already figured out that our common denominator is going to be 20 because 2, 4, and 10 all divide into 20 evenly. So I'm going to multiply every single term by 20. And I want you to see how easy that can be, no matter how difficult the fractions are. So I'm going to come up here. I'm going to multiply everybody by 20. Oh, this lighting, I swear. Maybe way worse. Better. I think that's what I got to do. I have to like turn the light on and then shut it off. But then it just goes under. What do you want from me, lighting? Okay, that's a little bit better. All right, so here's what I mean by divide down, multiply up. You're literally just going to take your whole number out in front, you divide down, you divide by whatever the denominator is, multiply that number by the numerator. I know you know what 20 times a half is, but you know, maybe you don't know some of the trickier ones, but if you just follow that same process every time, you get the answer, so easy. So divide down, multiply up. 20 divided by 2 is 10, times 1 is 10x. So I get a 10x there, and now I'll do the 20 times the 3/4. Divide down, multiply up. So 20 divided by 4 is 5 times the numerator is 15. So I have a negative 15 right there. See how easy that is? So much easier, in my opinion, than doing 20 times 3, which is 60, and then doing 60 divided by 4. Yeah, you still get the 15, but this is so much faster and keeps your number small. Don't forget to do this one. 20 divided by 10 is 2 times the top, 14. Not bad, right? Not bad. Hopefully you agree. And now I have a very easy equation to solve. So I'm just going to solve it like I normally do. So let's go ahead. We'll add the 15. Bless you. By the way, just as a general rule, your answers, feel free to leave them as improper fractions. I can't, maybe if it's a certain type of word problem, you might want to change it to a mixed number, but we leave it as improper. You should reduce all fractions, right? So that's different. This one does not reduce. I don't have any common factors between 29 and 10, so that's the best I can do. The only other thing you might do is turn it into a decimal, but there's no need, so just leave it. Does that make sense? Okay, let me give you one to try. I'm gonna make it up here. Let's do, how about 2/5 minus 3/10 x equals 5/6. Try that one. I have no idea what the answer to this one is. I don't know if it comes out nice, but did anybody get an answer? You did? Jimmy, what'd you get? 13 over -9. Did anybody else get that? You did? All right. So that's probably the right answer. Let's take a look. What is the common denominator that you found? Everybody. 30. Yes, 5, 10, 6 all divided into 30. So let me multiply everybody by 30. And using my cool little divide down, multiply up. It's not really a trick. I mean, it's just math, right? But math is magic. So I can get these values really easily. So if I divide 30 divided by 5, I get 6 times 2. That's just a 12. That's not so bad. Divide down, I get 3 times 3 is a 9x. Divide down, 5 times 5, I get 25. So much nicer, right? And now I can just solve this. Hopefully easy peasy. -9x, that's going to be a what, 13? Oh, I'm a little bit off. Oh. So I agree with our final answer, a -13x. Okay, what about something like this? Try that one. Oh, I heard the right answer. It's no solution. If you, just before you kind of get into, let me clear the fraction business, if you look, I do have some like terms here, right? Isn't x minus x, it just goes away, doesn't it? So that leaves me, if I cancel out those x's, that just leaves me with a negative 1/3 equals 2/9. Is that true? No, it's not. My variables are gone, and that's not a true statement. So what does that mean? No solution. Even if you didn't realize that, if you went ahead and cleared the fractions, you're still going to end up, your variables would still cancel out, and you'd sort of be left with nothing. Nothing that works. Let's try another one where we mix some that are fractions and that are not fractions. So what if I did something like 2x plus 1/3 equals 5, 6. Let's throw another x on here. Something like this. Let me let you try it. Go ahead. You try it first. Let's see. This one should have an answer. It's probably not a nice number. I have no idea what the answer is, but does anybody get one? Grayson, what'd you get?
I got
-2/7. Anybody else get -2/7? Yeah, all right, let's see how. So this time I don't have any immediate, like it's not like the last one where I had two like terms on the same side. So I do have two x's, I noticed, so I will want to get them together, but I don't want to deal with the fractions. Let's clear the fractions first, and then we'll go from there. So I'm looking at my denominators, 3 and 6. So the common denominator would be, what'd you say? 6, yeah. So here's the thing though, I have to multiply everybody by 6, not just the fractions. Every single term gets multiplied by 6. So that means this one is now 12x. This one, divide down, multiply up, that's going to get me 2. Divide down, multiply up, I get 5x over there. Does that make sense? Okay, we all got to, all right, now I can go ahead and get those x's together. I might minus the 12x. So what's that, a -7x, and then divide by a -7? There it is. Thoughts? We're okay so far? Ready to step it up another notch? I knew you'd be ready. Let's try. I gotta put the page down. Okay, what are you gonna do with? I'm trying to find one on the sheet that's not so crazy. I'm gonna make it a feeling. It's a little hard, a little fast over there. Okay. All right, let's try. Let's do 4 times 3/4 x minus 12 equals 1/6. Something like this. Oh, you could even see it. I think what I need to do is bring in like darker curtains or something. See if I can make the lighting better. Anyway, all right. What are you gonna do with something like this? Any thoughts? Is it Adam?
Yes.
Yes.
Could you distribute and then clear fractions?
Exactly. Before you clear fractions, if there is any distribution to happen, you got to do it first. But I shouldn't say that. It's not, you don't have to, but it's, you have to be really careful with your distributing or with your clearing the fractions. It's a mess. So if you want my advice, and I will never steer you wrong if I can avoid it, we are going to always distribute first and then clear the fractions. So I'm going to add a big old star if the equation requires distribution. Do that first. Then clear the fractions. Okay, so this one I do need to distribute. How will I mean, you can, when you are multiplying a whole number by the fraction, really it's just 4/1, right? So you can just multiply the numerators. Here we get lucky because this one just cancels, right? And I just get 3x for that first piece. But when I go to do this one, I can reduce the 4 and the 12 and I just get a 1/3, right? So that would just be what, 5/3? You can also make it 20/12, but wouldn't that just reduce down to be that 5/3 anyway? Now that's just a 1/6, right? Because I'm only distributing right here. Does that make sense? Everybody okay? And now that I have distributed, now I want to clear the fractions. What would I multiply everybody by? 6 again, yep. So multiply everybody by 6, including that first term. So now I'm going to have 18x. Let's divide down, multiply up. So that'll be a -10. Divide down, multiply up. That's just a 1. And then I can go ahead and solve from there. What's the matter? Did I mess up? Oh, are you okay? Are you? Do you want some clarification somewhere? All right. Please let me know if I do something and I will mess up all the time. So please have no issues letting me know that I made an error, because I will make tons of mistakes. I'm telling you right now. So I'd rather you let me know, because I just constantly. I try not to. One time, oh my gosh, in Algebra 3 last semester, I taught the entire lesson wrong. Entire. I couldn't even post the video. I'm like, I'm not posting that. It's all wrong. It was awful. It was awful. I know. Well, the next one. So we're finally, I finished the whole lesson. I don't realize that it's wrong, right? I thought, I'm like, oh, yeah, great. And so then they start doing their homework, and then someone ran into a problem. And then they're like, I don't think that this works. And I'm like, oh, sure it does. And then we're trying. I'm like, oh my gosh. And then I went and I asked another teacher, I'm like, what did I, they're like, oh yeah, that's all wrong. So, whoops. I apologize to them 10,000 times. I don't know what I was doing. You could do, but you had to do all this other stuff. It was this weird factoring pattern. And, what a mess. So anyway, I'm only human. I will obviously try not to make any mistakes, but if I do, let me know. Okay. All right. Any hoosers, we're here. We're almost done. We're just going to add the 10, add the 10. 18x equals 11. Divide by that 18. Did you guys get 11/18? You did? All right. How are we feeling? Do you want one really hard one with the fractions? Okay, you got it. All right, let's try this one.
It's like my favorite thing.
Okay, we got some big numbers, but you guys can use a calculator. And don't be intimidated. You are Tantasquins. You can do this. I'm gonna double check that I didn't copy it down wrong, because that would be a tragedy. But I did not. I'll give you a hint on this one. This does actually come out nicely. Yes.
Can you read it?
Oh, sure. So we've got negative 11/5 x minus 5, and then in parentheses, a negative 13/4 x plus 23/7, closure parenthesis, equals negative 7,051 over 70. Feel free to use a calculator. Just go step by step. You do have a problem that has distribution in it. So start by distributing that negative 5 into that parenthesis. And there, so just if you're kind of lost, you're going to take that negative 5. It doesn't reduce with either of these denominators. So you're just going to multiply the numerators. I'll do that first step. So I need to distribute that 5 into this. I can't reduce the 5 and the 4, so I'm just multiplying the 5 and the 13. Negative times a negative is going to be a positive. So 5 times 13 is what, 65? So I get a 65/4 x. And now I have to do the negative 5 times the 23/7. So that's going to be a negative, right? I have a negative 5 times a positive, so that'll be a negative. 5 times 23 is 115. All over 7. And now on this side, I've got the negative 7,051 over 70. So now I'm ready to clear my fraction. You did the distribution. And if you look at those denominators, I mean, it's not, yeah, 70 is kind of big, but it's not that bad. We can find a number that they all go into. Here's my helpful hint, by the way. Take your biggest of the denominators, which is 70. Do all your numbers, 7, 4, and 5, do they all divide into 70? No. So then think about the next multiple of 70. The next thing that 70 goes into is 140, right? Do they all go into, all of these numbers go into 140? So there's your number. So if you take the biggest of your denominators and think about its multiples, that's, I don't know, that's, in my opinion, your fastest way to find what's going to work for everybody. Remember, divide down, multiply up. By the way, I don't know if I told you, but my calculators, if you're ever looking for them, there's the graphic calculators are on the wall. I wouldn't bother with those, but on the cart, there's a cart, a black cart sort of against the wall over there. That's sort of my my classroom carousel, and we've got calculators and scissors and protractors. And so should you need any of those items, you can help yourself at any time. Okay, did anybody get an answer? -6, I heard?
Oh, yeah.
That's the right answer. I thought I heard it. Maybe I was just willing it to existence, but -6 is correct.
Oh.
Ooh.
I got 4.5, 4.5691
So did
5, 6, 9.
Well, let's try it. Did you guys,
I messed up with my negative somewhere.
did you have this line? Did everybody have this line right here where we just distributed that 5, that -5 here? Yeah,
Wait.
okay, so you gotta distribute that -5 first.
Oh, there was a negative on the 13th. Oh, that's where I would have went wrong. I
Oh.
didn't see the negative.
So now I'm here and we talked about how 140 was gonna be our common denominator, right? Because that's the number that all of them will go into. Let's multiply everybody by 140. And remember, divide down, multiply up. So I'm gonna grab my calculator. 140 divided by 5 is 28 times that -11 up top. I get a -308x. Right, for that first chunk. And now I do the same thing. 140, I'm going to divide by 4. That's 35. Times it by the numerator. So I get 2,275. Minus, now I got to do 140 divided by 7 times that numerator, 115. 2,300. And then one left. 140 divided by 70 is going to get me 2 times that numerator. So 7051 times 2 is a -14,102. Of course, I'm going to run out of room. And now, yeah, they're big numbers, but there's no fractions. I can deal with this. So I've got these two like terms. Let's get them together. 2275 and a -308. Oops. That's going to be 1967x. And then I can add the 2300 to both sides. So that -14,102 plus 2300. I get a -11802. Divide both sides by that 1967. And fingers crossed. Yep, -6. Whoo! If you got that one, great job. Would I give you a question like that on a test or a quiz? I might, but not a lot, like 1. So they're doable. They're just frustrating because there's a lot of moving parts, big numbers. But I would certainly give you a calculator for something like that. Yeah, doable. All right. We don't have as much time as I thought we would. I still want to talk about decimals, but maybe we'll hold up decimals till tomorrow.
Yeah.
Okay. All right, so let's put a pin in it. Let me give you the sheet. And I will have you start working on what I want you to do for this evening. Here. You sure can. One for Grace. Yeah. You. So you wanted to put it on it, you want it, you would prefer to keep it fine. Okay, guys, so what I would like you to do, just numbers 1 through 19 odd. 1 through 19 odd. Also, the question was asked, do you have to put your work on this paper? That's your choice. If you feel like you can fit it all on here and it's legible, fine. If you prefer to just use a separate sheet of paper always, that's fine too. I don't care either way. Just please submit this when you are finished. I'll open it up on Jupyter. 1 through 19 odd.